always, we would like to thank our corporate partners for their support. They allow the Institute to assist the Institute in doing what we do and trying to raise awareness and improve standards and so on in the industry. So thank you to them, and also thank you to all our previous presenters. Last week we had Dave Paget, who chairs the technical committee for the IOR in the UK and also the mirror committee for BSI. So we did a great presentation, and Dave's presentation, as are all the other presentations, are available on our IOR website. So this week, we're delighted to have Fabrizio Spina from HPI. HPI is one of the notified bodies operating in Europe and Ireland, supporting CE marking for pressure systems. In Fabrizio's case, he's a certification engineer specializing in refrigeration systems, so he knows the requirements very well. And CE marking is a requirement for all systems over certain categories, and in category 2, hazard category 2, a notified body is required, such as HPI. And the part of the standard that's harmonized to the PED is part 2. So that's what Fabrizio is going to speak about today. So I'll hand over to you, Fabrizio, and you can start sharing. Thank you.
Okay, thank you. I would like to thank you, Declan, for this opportunity, and would like to welcome everybody to this webinar. I share my screen. Okay, I believe that's it. So
that's it, yeah, thank you.
Okay, I can start. In this session, we will review the main step for the certification of assemblies according to the Pressure Equipment Directive. So we will check the key steps in the conformity assessment for refrigeration assemblies and the application of the EN378 Part 2, and specifically its Annex ZA to meet the essential PED essential requirement. So we will refer to the Annex ZA to describe how this standard can be applied to fulfill the PED requirement. The PED regulates the placing into the EU market of the pressure equipment and assemblies. A product is placed on the market when it is made available for the first time on the union market. Each product can only be placed once on the union market. Assemblies are subject to a global conformity assessment. So when a system is manufactured to be sold in the EU, it must be assessed and certified according to PED. Once it is placed on the market, national regulations apply. For example, repairs such as replacement of components like are not covered by PED. There is an exception. So when the installation of CE market components is made under the user responsibility, the PED doesn't apply, since basically there is no placing on the market, because placing a product on the market requires an offer or an agreement between 2 or more parties. The main structure of the global conformity assessment. The global conformity assessment is made by three parts, 3 main steps. The assessment of individual items, the integration of the parts, and the installation of protective devices. The first step is the assessment on the individual items. So all items falling into category 1 to 4 need to be subject to conformity assessment procedures. The category definition is based on the equipment type, vessel, piping, or boilers, the fluid, flammable or non-flammable, gas or liquid, and the combination of pressure and volume. The PED includes 9 tables in the Annex 2 for this classification. This assessment foresees basically two cases. The case A, both items, so when components are already CE marked, typically vessels or relief valves, or manufactured items. So when the manufacturer is responsible for assuring that the items it makes have been subject to a conformity assessment procedure. Typically, these items are the piping. There's no need for the manufacturer to CE mark only these specific items, for example, the piping, because the CE mark of the overall assembly will include this. The second step is the integration of components. The manufacturer needs to assess the integration of the various components of the assembly, the allowable parameters, based on the defined allowable limits of the assembly. That means that the manufacturers need to assess the pressure and temperature values for each items. So when the allowable limits for the assembly are defined, for example, a value for the high side and a value for the low side, each item needs to have allowable limits equal or higher than those, including the temperature. The manufacturer needs to choose the modules. The modules is based on the category. The category of the assembly is determined by the highest category applicable to the equipment, other than that applicable to any safety accessory. So, if the highest category among the components is 3, then the entire assembly is classified as category 3. The category of safety accessories, which is category 4, can be taken into consideration. The components with the higher category is usually the liquid receivers in a refrigeration system, but the design parameters of the assembly must be considered, not those of the liquid receiver. That means that a vessel category can be modified within the assembly evaluation. That is, the PS value can be reduced according to the safety device set pressure. This reduced PS may result in a lower category. We will see an example later. The third step is the protecting against the permissible operating limits being exceeded. So, suitable protective device must be installed. Safety accessories, which are always required, and where appropriate, adequate monitoring devices. Monitoring devices alone are not sufficient. Monitoring devices that enable adequate action are, for example, a pressure transmitter that activates an alarm. This is a simplified refrigeration assembly. We can start with the compressor, already CE marked, so it is a both item. We have the condenser, already CE marked, so it is another both items. The liquid receiver, CE marked, so both items. Category 3, PS20 bar, suitable for group 1 or group 2 gases. The evaporator is both items already CE marked, so these 4 equipment are already CE marked. The piping, which is made by the manufacturer within the assemblies, is a manufactured item. So the manufacturer needs to submit this piping to a conformity assessment. We have the compressor with a discharge pressure of 15 bar in that example. So the high side is 15 bar, the low side is 10 bar. Once this allowable limits for the assembly are defined, we need to verify that each component has a equal or higher PS than 15 or 10 bars. So the condenser is 25, so it's okay. The receiver is 20 bars, so it's okay, and the evaporator is 10 bar on the low side, so that's okay. The high side is fitted with 15 bar pressure relief valve, so we can evaluate the category of this receiver, which is typically the highest category in the assembly, using the value of 15 instead of 20. So this assembly could be category 3, but if we check the category of the receiver using as PS 15 bar, as operating fluid gas group, group 2 gas, since it is suitable for both group 1 and group 2. We use 15 bar group 2, this liquid receiver can be classified as category 2 instead of 3. So the whole assembly falls into category 2. Now we can move on to the technical requirements and discuss how to meet the PD obligation from a technical perspective. For refrigeration systems requiring CE certification, the reference standard is the EN378 Part 2. That is what we call a harmonized standard. But what does harmonized mean? The definition of harmonized is set out in the Blue Guide. The Blue Guide provides guidance and explanation on the European Conformity Assessment System, on the CE marking, and the market surveillance. It includes general definitions such as manufacturer or placing on the market. I'm not suggesting that everyone needs to read this document, but if you are in doubt sometime about some definition like manufacturer placing on the market when more the two parties are involved, you can try to find some good information in this document. So the definition of harmonized: product manufactured in compliance with harmonized standards benefit from a presumption of conformity with the corresponding essential requirement of the applicable legislation. So an harmonized standard is one that, when followed, provides a presumption of conformity with the essential requirement on the applicable legislation, in this case, the directive. The list of harmonized standards is published on the official journal of the European Union. You can find this document on the web. The last revision, the last issue is January 2025. You can find the reference to the directive, the PD directive. The EN378 Part 2 is the only one standard in the EN378 series listed as harmonized. So the Part 2 is the only standard harmonized to PD in the EN378 series. We can also identify that the standard is harmonized to PED when it includes the Annex ZA. For machinery directive, the Annex ZB is used instead. The Annex ZA provides a table showing which PED essential safety requirements in this column are addressed in the standard and where the relevant technical requirement is described. So adequate strength, essential safety requirement 2.2.1 is addressed in the clause 6.2 of this standard. There's a note. As long as a reference of harmonized standard is not published on the official journal, the harmonized standard or part thereof does not give presumption of conformity with essential or other requirements it aims to cover. This definition is also on the Blue Guide. That means that to consider a standard as harmonized, it must be published on the official journal. One example is the EN 24664, which includes the annex ZA, but is not harmonized yet because it's not published on the official journal yet. Now we can start reviewing the main points of the EN378 Part 2, as outlined in the Annex ZA. So we can use this. We will evaluate all these points, the main points listed in this annex. 6.2.2 Determination of the maximum allowable pressure. The maximum allowable pressure, PS, must be defined in the different parts of the refrigeration system, typically the high side and the low side, take into account the maximum ambient temperature and relevant factors. Relevant factors are max ambient temperature, method of defrosting, for example, solar radiation, fouling. All these factors must be considered when defining the maximum allowable pressure of the system. The component maximum allowable pressure shall not be less than the maximum allowable pressure of the system or part of the system. It is the same that we saw before about the integration of the system within the global conformity assessment. The selection of material for component shall take into account the impact strength at all temperature to which they may be exposed. The application of certain materials at low temperatures may request special consideration due to risk of brittle fracture. This is a very important point. Copper and arsenic stainless steel are not subject to brittle fracture. So when you use a copper or arsenic stainless steel, you can ignore the impact strength and the brittle fractures, but particular attention must be paid when using ASTM carbon steel for temperature below 0. Harmonized material, for example, the EN 10216, always require impact testing. So when you are buying material according to an harmonized standard for a carbon steel, it will always be provided with an impact test. For STM materials, the situation is different. For example, the A333 grade 6 has impact test at minus 45 degrees, but for A106 grade B, no impact test is required by the standards. This is not compliant with what PED asks. So precautionary steps must be used. The most common and the option that we recommend is to require a specific impact test at a minimum design better temperature. And this test, the rest of this test must be included in the 3.1 certificate for the material. The ASME code and the EN standards take fundamentally different approaches on the using at low temperature. The ASME code relies on historically experience of safe use, so it accepts a small percentage of risk, as material in the standard are usually specified with a range of chemical composition and mechanical properties. This variability can lead to differences in performance at low temperature. So we could have a good steel or a bad steel. So the historical use of the history of safe use is not doesn't guarantee that this material can have good properties at low temperature. So summarizing, impact test is always requiring for material for carbon steel for use below 0. 6.43 piping. Piping joint the fitting shall comply with the requirement of EN 14276 part 2. We will check this point later. Spacing for pipe supports. The recommended maximum space is for spacing for supports is specified in table 5 and 6 of the standards. Table 5 for copper, table 6 is for steel. We have here an example of a snapshot of the table 6, the table 5. Protection devices. In a refrigeration system, the pressure during operation at standstill shall not exceed the maximum allowable pressure in any part of the refrigeration system. If a pressure relief device is discharging, the pressure in that part of the system shall not exceed more than 10% of the maximum allowable pressure. That means that a safety device must be set at the maximum or allowable value of the allowable pressure of the side of the system. For example, for outside, if we have an outside at 20 bar, the PRV must be set at 20 or lower. And when the device is fully open, the part of the system can exceed more than 10% of the set value. This is because this 10% is the overpressure necessary to overcome the PRV spring resistance. And all the safety valves that you can find on the market, basically all of them have overpressure of 10%. This is why the standard describe this 10% value. Electromechanical safety switching device for limiting the pressure. The system can be provided by electromechanical or electronic safety switching. In both cases, the safety function shall be separated by the control function. So this device must be used only for safety. Application of protection devices. Protection device shall be provided for both the refrigeration system and the secondary heat transfer circuit. So when manufacturing hot water for manufacturing heat pumps, the hot water circuit must be provided with protection devices. Wherever practicable, a safety switching device for limiting the pressure shall be used to stop the pressure source. This is typically the pressure switches for compressors. Protection of refrigerating systems against excessive pressure. All protection devices shall be type tested and certified. That means that they must be PED certified as category 4 safety device. The exception is for the device that protect only the compressor. That means that this device can be not certified, but in this case, they can be used to protect PED vessel or piping. So when we have compressor provided with PRVs that protect only the compressor, it can be used to protect the condensate or the oil separator. You need to install a certified PED category device for category 4 devices. Device used for protection of the parts of the refrigeration system shall be set according this rule. So when switching device only are used, honestly, I haven't never see that configuration. The set pressure must be like the PS or lower. When a pressure relief device is installed, the set pressure must be equal to the PS or lower, and the pressure relief device shall be fully open at 1.1 per pressure, the same 10% overpressure we saw before. When pressure relief devices and safety switching devices are installed, the switching device must be set at 0.9 times the setting of the relief valve. We usually have the situation when the pressure relief valve is set at the same value of the PS, and the safety switch, the pressure switch is set at 0.9 the PS. Isolating valve can't be installed in the inlet or outlet of a pressure relief device, except as specified in this point. This is the point, and locked valves are permitted in between a compressor and its safety device in open position, between pressure relief devices and the pressure vessel which they protect, provided they are secured in the open position by means of a lead, seal, or equivalent. Equivalent means a system where accidental operation is prevented. For example, to close a valve, a preliminary action is required, like removing the seal. Before the actual closing, the operation can be performed. When locked valves are installed, this seal shall be clearly marked. That means that it needs to be identified on the valves with signals on the stickers, and it could be also useful to note this valve on the P&ID. We have here an example. We have this isolation valve that can isolate the condenser and the oil separator from the pressure source from the compressors. In this case, the valve used is a rotolock valve. They put the client put a note on the PND IND and put a note physically on the valve with the stickers, and so the valve was locked in open position, and this configuration can be accepted. Sizing calculation. The sizing calculation of pressure relief device and up and downstream piping shall be calculated according to 13136. And this calculation must be included in the technical file. We are now in the situation where this standard is withdrawn and superseded by the EN 24664. As we saw before, this standard is not published on the official journal yet, so it can be considered as harmonized, even if the standard includes the Annex A. At the moment, HPI is accepting calculation using both standards because the EN 13136 is the actual harmonized standard, but the new standards give more information about, for example, a common needle when multiple valves discharge in a common needle, so it could be useful to use that valve in those cases. Discharge from pressure relief the valve must be in a way that people, persons, and property are not endangered. That means, for example, discharge above man height or in a safe location. Testing. The refrigeration installation must be subject to testing. These are the points described in the standard. The stern pressure according to 0.632. We will examine these points later. Tightness stress, functional test of safety switching device, a conformity test the complete installation. For point A and D, the witnessing of the notified body is required. For points B and C, evidence is sufficient, so including evidence in the technical file is sufficient. Joints, especially welding joints, shall be accessible for inspection, while strength pressure tests are in progress. That's to allow the inspector to verify if leakage, if there are leakage or not. The result of this test shall be recorded. So the strength pressure test, we have basically two cases. The components when already tested, so that means already CE marked, or so both items, and components that are not tested. So for example, the piping, when the manufacturer also manufactures the piping within the assembly. For the components already tested, we don't need to witness the pressure test, so we accept an operating test or a leak test. For the manufacturer items, a strength test is required. So for piping, there are two different options for the strength test. The piping of category 2 and higher, and the piping for category 1 and lower, so category 1 and SCP piping. For category 2, this first point is addressed in the next slide. Individual proof test at minimum 1.43 PS is required, so these are the option for piping of category 2, or perform the test as described in the EN 14276 part 2, or a pressure test at 1.43 PS, or a pressure test at 1.1 per PS, and in addition 10% of non-destructive testing on the permanent joints. This test must be magnetic particle or ultrasonic testing. In this slide, we can check the option 1. This is a snapshot of the EN 14276 part 2. Category Y piping is the same that category 2 or 3 of PED. And it foresees two cases. The case 1, which is the same as before, a pressure test as 1.43 per PS, on a case 2, which is similar to the second point, the third point in the previous slide, which is a pneumatic test at 1.1 for PS, 10% of visual inspection, and NDT. NDT on circumferential wells must be done 10% radiographic examination or ultrasonic examination. It depends on the DN. It could be 10% of the numbers of wells or 10% of the total length as well. It depends. And also for well configuration and dimension, when UT or T doesn't allow a clear assessment, PT, so dye-penetrant examination shall be carried out. This is typically for copper piping with small thickness. So if the outcome is the same as basically the same as the previous slide. So 1.1 pneumatic test and 10% on NDT. This is the option for category 1 or lower. So carry out the test required for piping of category 2, of course. So you can apply a stricter requirement, or test the piping at 1.1 per PS. So when you have an assembly with piping category 1, you can just perform a pneumatic test. As general note, the strength test pressure for the strength pressure test safety device may be removed if necessary. The pressure test for each side can be made separately. So for one test for the outside and one test for the outside. The fluid preferred is oxygen-free nitrogen. When performing the pressure test, is necessary to use a measuring equipment that fulfills some requirements. So the pressure gauge must be properly calibrated. A ISO 17025 accredited laboratory must be used for the calibration of the gauge, or the gauge must be calibrated based on another gauge calibrated by the accredited laboratory. The calibration certificate must be available on site for the inspector to be checked. If you are in doubt if a laboratory is accredited or not, you can check on the INAB website. The inspection of refrigeration systems. The notified body is involved for category 2 systems and above. The inspection must be performed by a competent person. This competent person is not the notified body, but is the person, someone within the company. And now we can check the points required for the inspection. Checking the documentation relating to pressure equipment, for example, declaration of conformity, instruction for use, or certificates for PRVs, including set value. Checking the safety device according to this point, and these are the points outlined. So fitted and set pressure must be clearly defined, compliant with appropriate standard and CE certified. Safety switching must be functionally fitted correctly. On pressure relief valves, the set pressure must be stamped on the valve on a data plate. Same thing for the bursting pressure on bursting discs. Checking that selected welds on piping are in accordance with EN 14276. Same thing for the bracing joints. And basically it means that welding and bracing procedures and personnel qualification is suitable for the selected process and material. Procedure and personnel must be approved by a recognized third-party organization for category 2 and above piping, and joint must be tested as specified before in the standard. Checking the refrigerant piping, that means installed in accordance with the drawing. Checking the documentation on the alignments of the drive couplings of rotating parts. Checking the record of the tire test. These 2 points are not really related to the pressing containing aspect, so we are not really checking this during our inspection. Visual inspection of the refrigeration systems. That means an inspection of the complete installation. And as last point, checking the marking according to the point 642. The point 642 specifies what must be displayed on the identification plate, and that is the name and address of the manufacturer, model and serial number, year of manufacturing. The year can also be part of the serial number, so there's no need to specify only the year if your model number include also the year of manufacturing. The designation of the refrigerant charge, the maximum allowable pressure, and I can say also temperature. The flame symbol when flammable refrigerants are used, and the CE marking when applicable directives are applied and satisfied. This is an example of a CE mark, a CE nameplate of a customer of us. We can see here the CE mark and our notified body number, and the other information are specified in this standard. So thank you for your time and attention. I hope this presentation has given you a clear vision of this standard and its role in ensuring compliance with the Pressure Equipment Directive. Okay.
Well, thank you, Fabrizio. That's excellent. Fantastic presentation, and we're just coming up to 2 o'clock, so we ran a little bit over, but there was some fantastic information in there. So thank you all for staying on. So the presentation and slides will be available on our website as soon as very shortly. The next webinar, we're taking a break now for a few weeks for holidays, but the next webinar is on the 21st of August, and we have Jonathan Quigley from the NSAI who's going to walk us through the process of submitting comments. So 21st July lunchtime, Jonathan will be presenting. Now just be aware that the closing date for public comments is the 28th of August. The technical committee members from SEN TC182 Working Group 6 can submit comments up to the formal closing date later in September. But for the public, it closes on the 28th of August. So if you participate in the process, and please do go to Your Standards, Your Say on the NSA website, and you can access the proposed documents there and submit your comments. Now, obviously, you need to know what the current standard says. That will help a lot. But please do participate in that. So we're on our summer break. Thank you to Fabrizio and all our other presenters. This is the 7th. It's been great. We've had maybe 20 to 40 people attending each one, which is fantastic. 21st of August, so 3 weeks. We have a break for 3 weeks, and then Thursday 21st. Thank you for attending, and please do participate in the Your Standards, Your Say process, and that will give you the opportunity to follow the proposed changes and influence the standard. So thank you, everybody, and we'll close the presentation. And thank you all for staying on. And best wishes for the summer, and hopefully see you all on the 21st of August. Thank you.
Thank you. Thank you, everyone.